Hey guys, welcome to Unit 3B. It is election night, so to keep my mind off the anxiety of waiting on the results, we're going to go ahead and make some math videos. So let's go ahead and start graphing quadratic equations. So we've talked a little bit about what quadratic equations look like when you put them on the coordinate plane. But in this unit, we're going to be focusing a lot on how we put them on the coordinate plane and what sort of characteristics they have once you get them there. So for this lesson, we're going to be graphing quadratic equations from standard form, which is the form we're most comfortable with at this point. So our learning target is that we can graph quadratic equations from standard form. Pretty straightforward. We do have quite a lot of vocabulary this time, but several of them we've already defined in previous units. So we just went ahead and put those in your glossary for you. You don't have to recopy them. We already know that a quadratic equation is an equation with second degree. We already know that the roots are the x values where the output is 0. We also know that this is sometimes called the x-intercept or the zeros or the solutions. It has lots of names, but it's all the same thing. And it's where the graph intersects the x-axis. The new information is the axis of symmetry. So once we get all this down, I'm going to have you pause the video and get this written. But we have a formula for the axis of symmetry. It's a line that divides the parabola into two equal halves that are reflections of each other. It comes in really handy when you're trying to graph points, because once you find one point, you can just reflect it over that axis of symmetry to get a twin on the other side. It also passes through the vertex. The formula for the axis of symmetry is x equals negative b over 2a, and that's going to be really important as we get into the lesson. Okay, so go ahead and pause and get that written down. The next thing is a horizontal shift, and this is something that we're going to talk about more later in the course, towards the end of the course, but it is a transformation that shifts a parabola or anything either to the right or to the left. Previously, when we defined parabola, we just kind of looked at what the shape is. So I'm going to give you a more formal definition this time, slightly. It is the graph of a quadratic function. It's a curve called a parabola, and it looks similar to a U. And we're going to get really familiar with that soon. Right, we've already talked about these. Do remember that standard form is ax squared plus bx plus c with a not equal to 0. Okay, and then the last one is the vertex. The vertex of a parabola is the maximum or minimum value. It's either in terms of y if the parabola is opening down, or in terms of x if it's opening to the left or right. We are going to be almost exclusively looking at parabolas that are opening up or down, so it's going to be looking at a y value. We also have a formula for this, and we're going to give this to you again later, but for the x value of a vertex, it's going to be negative b over 2a. It is going to be an ordered pair because we're looking at a point on the coordinate plane. So the y value is going to be f of negative b over 2a. Basically, you're going to take the x value and plug it in, and that's going to get you your y value of your vertex. We're going to practice that some more. Okay, so let's go ahead and get to the lesson now once you've got all this written down in your glossary.